The objective of this video is to go back over function composition, which you learned in part 2 of your 10.1 notes, but I want to end with a real life example and just to make sure it's really clear why we use this symbol that you learned in part 2 of your videos. So I'm going to start with an example that has no numbers. So let's let f of x represent the slices of bread, and let's let g of x represent your egg omelet. Now these two mean function composition. It could also be read like, or it could also be written like this. Okay, that's how we wrote it in part 2. These mean the same thing. So these two are equivalent. Okay. So what this is saying is to take function g and plug it into function f. So to take function g, which is the eggs, and put them into the bread. So that would look like this. And that's what we're used to. Whereas if we switch the order, I want to show you it does mean something completely different. So this one is saying to take function f, which is the slices of bread, and put them into the eggs. Now I'm sure there's some people out there that might do this, but most normal people make sandwiches with the bread on the outside. But the point of this is just to give you an example without numbers that these two do mean that this does mean something different, and that it always goes from right to left. So you put this function output into this function's input. Okay. So now what I'd like to do is I would like to talk about an example with shopping. In particular, this is going to be about Kohl's because I love shopping at Kohl's. They do lots of coupons. So let's pretend we have these two coupons. We have a $10 off coupon, and then we have a 30% off our whole entire purchase coupon. So let's pretend we go to Kohl's, we put a bunch of stuff in our shopping cart, and it says, let X represent the total of all your items before coupons and tax. So that's what X represents, how much we're about to spend before the coupons are applied and the tax. So it says, write a function using f of x to represent the total of all your items before tax if you're only allowed to use the $10 off coupon. Well, if x is how much we spent, then we're just going to subtract 10 from it. So f of x just represents like the function's name. So x is our input. We're going to input how much we spend on all our items and then take off $10. Okay. Part 2 says, what if you were only allowed to use the 30% off coupon? Now to understand the equation for this one, so it says to use g of x, so we know we have that. But to understand how to write the equation, we have to know a little bit about percents. So because it says to take 30% off, we have to understand that 100% represents the whole cost of something. So if you're going to then take 30% off, you're not going to pay for the whole item. You're going to only pay for 70% of the item. So we're not going to use 0.30, but we're going to turn this into a decimal, and it would be 0.70. So if we want to take 30% off, we're going to multiply how much we spend by 0.70, or just 0.7x. So we can write this like this, or we can write it, because we know with decimals we don't need to have that 0 there. Okay, so we can write it either way. So just to make sure we understand, if we had a 40% off coupon, which sometimes Kohl's does do that, I rarely get that, but instead you would have 0.6. So because this is being taken off of the whole 100, that's how we know what our decimal is in the problem. Okay, so anyways, that was a little bit of a review of percents. Now let's get back to our objective here. So if I asked you to find f of g of x, this is saying to take function g and put its output in for function f's input. So I'm going to take function g, so this one, and put it in right here. So it's going to be, so I'm going to take function g, so this is function g, and put it in right here. Okay, so then it asks, what does this represent? Well, to explain this, we need to do order of operations. So in order of operations, if we knew what X was, let's say we spent $100, does it do the minus 10 or the 0.7 first? So in order of operations, you multiply first. So this means if this is what Kohl's programmed into its register to do when you go and this would represent you're allowed to use both coupons. So each of these means you are only allowed to use one. Now this is saying, oh, well, what if Kohl's allows you to use both? It has both of them in there. So this is a real life example of when you would use this symbol here, when you have two different functions and you want to do this. We want to use both coupons. So the register is going to first, this is order of operations, would do this. So first, it takes off the 30%, and then the $10 off. Okay, so that's what this would represent in a real life context. Now this time, let's switch the order. So this time, let's plug in f of x in for g. So this time we're going to plug in the x minus 10 right here. So we're going to have the 0.7, and instead of the x, we're going to plug in x minus 10. Okay, so now what does that represent? Well, order of operations would tell you to do parentheses first. So if Kohl's register was programmed to do this function, it would take, first, the register would take off the $10, and then the 30%. So the point I want to make here is the order does matter. And again, here's a real life example where Kohl's allows both coupons, and whoever programmed the register so that the register, when they scan all your items and your coupons, and how does the computer know which one to do, right? So somebody has to know this kind of math so that the computer can be programmed for the correct composition. So now this last problem, you would only know if either you've worked at Kohl's or you've gone to use coupons as to which one does Kohl's do first. Do they take the 30% off first, or do they take the $10 off first? Well, stores are always going to do what makes them more money typically, right? So let's see which one. So we have 0.7x minus 10. So we have f of g of x versus if we have this one. So if we want to know which one would Kohl's really do, which one would benefit them more. So let's pretend we let x be $100. Let's say we spent $100 at Kohl's before tax and coupons. So if I plug in the 100 here, so let's go ahead and calculate this. So this would take off this 30%, so 0.7 times 100, that would be $70 minus the $10, so they would do the $10 after. That would mean if you spent $100 after the coupons, you're only paying $60. Let's see what happens here. Here, they would take off the $10, so that would be $90, and then the 30% off, so times 0.7, you're paying $63. So the one that was more is this one. So the one where you do the parentheses first. So that is how I know that this is the one that Kohl's does. So to recap here, what I want you to get out of this is, here's a real life, I do this all the time when I go shopping, especially if I'm trying to earn, they have this deal at Kohl's where if you spend $50, you get $10 off, and I want to predict what my total is going to be before I go through and check out, so that way I earn my Kohl's cash. I'm before I go through the register, I am calculating with my phone or in my head how much I'm going to spend before. So I need to know which way, if I have both of these coupons, which way is the correct way that they, the order that they take off their coupons. So again, as you can see here, it does matter. If I spend $100, here I'm spending 60 versus 63. So the point is that these two mean something different. Okay, so I want you to get that the order matters, okay, that the way you do this, and here's a real life situation of where you could use function compositions.